Hello everyone, we are here to do an example problem. We are going to be doing an example from our one-dimensional kinematics notes. And let's go ahead and go down to that problem right here. It's example 1 in the one-dimensional horizontal part. And it says a car accelerates along a straight road from rest to 60 kilometers per hour in 5 seconds. What is the magnitude of its average acceleration in meters per second squared? So what I'd like you to do here is remember that when we're going to solve problems that we do need to represent the situation that we're looking at in pictures, words, graphs, and equations. So we're going to start off with drawing a picture for this. So I'm going to have you go ahead and stop and think here about what your picture might look like. When you've drawn your picture or thought about it, I'd like you to pick up back with what I've started with. All right, we're back and we are looking at the example. I've drawn the picture. We know the car starts at rest, so originally our initial velocity here is going to be 0 meters per second. We know that it reaches or it attains some speed here, and we're going to call this 60 kilometers per second, or sorry, 60 kilometers per hour. And it does so in 5 seconds. So the 5 seconds is an elapsed time between here and here. We also know that it's accelerating, in this case, getting faster, so the acceleration has to be in the same direction as our motion. As in all problems, we're going to define some positive direction. In this case, I've called to the right positive. Again, that's kind of an obvious choice because of I have an acceleration here to the right and a velocity to the right. So what I want to do next is I want to write down my knowns, and in this case, let me just move this up just a little bit, and you're going to notice here that my knowns, again, like I said, 0 meters per second, my final velocity is 60 kilometers per hour, and the time that it takes is 5 seconds. Now, one thing I always want to check here is check units, and I'm noticing that these two units do not agree. I've got kilometers per hour and meters per second, so I need to do a conversion. I haven't shown that conversion here, but I would assume that you know how to do that and actually show it. Again, if you need to reference factor label method, you can always go back. What are we asked to find? We are asked to find the acceleration. And specifically, we're worried about the magnitude only. In other words, we're only really worried about the amount of it. We're not really worried about the direction. We're not really worried about the vector part of it. We're really just worried about the amount. So we're going to actually look for an equation. So I'm going to have you go ahead and peruse the equations, think about what you do, and get back to me. All right, we're back with our equation. The equation I chose to pick here, and again, this is just one of multiple equations you could pick, is the average acceleration equals a change in velocity over a change in time. Now, of course, a change in anything means a final minus an original. So you can see here I've substituted in final velocity minus an original velocity. It just so happens that since my original velocity is 0, I just kind of cancel this out, and or I'm kind of effectively substituting in a 0. Likewise, the original time, the time that starts over here, where we'd start our stopwatch, is 0 as well. So that gets crossed off as well. Or again, substituting in a 0, we would get that. So ultimately, what we get for our equation here, I'm just going to shrink it down just a tiny bit, is we do get our VF over our TF. And it's always a good idea to check your units to make sure this works out right. And doing our unit analysis here, I noticed that VF would have units of meters per second, and TF would have units of seconds. So basically dividing meters per second divided by seconds, that's equivalent to meters per second times 1 over s. Remember, when you divide by something here, it's like multiplying by the reciprocal. Multiply across the top and the bottom, we get meters per second squared. And this is actually a good thing. Units turn out to be okay. I do expect meters per second squared for the acceleration units. Next, time to put my numbers in. So I put the numbers in from the known section over here. And when I do calculate out, I get a magnitude of 3.34 meters per second squared. So again, because they're asking for the magnitude of acceleration here, we are not worried about uh, the positive or negative direction here. And now, of course, in the case of this problem, because the acceleration is in the positive direction, if they ask for what is the acceleration, and we were worried about the vector part of it, we'd have to put the positive in. But because we're not asked for that, we don't need to in this problem.